Hi everyone, how are you? Students, in today's lecture we will discuss about stellar mass black holes. First of all, we will discuss about birth in isolation. Students, stellar mass black holes are born during the violent deaths of massive stars. If the star in question wandered through space as an isolated star, like our sun, then a black hole formed as a result of the star's death would also be an isolated black hole, as represented by this image. Since isolated black holes wander through space without a companion, they have little to feast upon. As a result, there is little material for them to consume, and so they can virtually undetected. Such isolated black holes can also be formed by a different route. Stars are more generally birthed in multiple, so as binaries, triplets, quadruplets, and so on. If one of the star is a high mass star, it will burn through its fuel more rapidly than others in its family. At the end of its life, it will explode in a violent supernova explosion. One such supernova explosion is represented by this image. This explosion can provide a kick that, if strong enough, would break up the family, throwing the black hole out into space by itself. The ejected black hole may even be on a trajectory that throws it out of the disk of its host galaxy. If, however, the kick is small, the binary will remain intact, providing the black hole with a handy food source to munch on for many years to come. The next topic is about finding stellar mass black holes, means where we can find them. Since stellar mass black holes are the end point of a star's life, they can occur anywhere you would find stars. This means that stellar mass black holes are found scattered throughout galaxies. They can be seen around the core of a galaxy or at its outer limits. Almost all of the known stellar mass black holes have been found in binary systems. But this doesn't mean that black holes in binaries are more common than isolated black holes. Instead, this is most likely due to selection bias. One such binary is represented by this image. Students, in science, whenever we choose a sample based on how easy it is to find instead of how common it truly is, we introduce a bias called selection bias. Actively feeding black holes in binaries are much easier to spot than their fasting counterparts. That means that we are much more likely to detect stellar mass black holes in binaries when we look at the night sky. Students, this is all about this lecture where we have discussed about stellar mass black holes and its detail. Thank you so much.